Questions 11 through 20 on the 2021 Grade 12 AMC 12A. A laser is placed at the point 3, 5. The laser beam travels in a straight line. Larry wants the beam to hit and bounce off the y-axis, then hit and bounce off the x-axis, then hit the point 7, 5. What is the total distance the beam will travel along this path? Well, we are starting at 3, 5, and we have to then go to some point here, and then we bounce off and go to the x-axis, and then we bounce off again, and then eventually end up at 7, 5. Now, what is critical to understand in this question is the angle. Since we're going straight down and then bouncing off, then that means we are hitting at pretty much right angles if we compare them to each other. And I think that's very critical because that allows us to figure out the distances. Okay, so let me just draw one line that goes from there to there, and then one line that goes down there. Okay, so these are going to be right angles right here and here. Therefore, this is 45 and this is 45. If that is true, that means this is equal to that. And therefore, by the same story, this is equal to that, and this is equal to that in terms of the side lengths, since these are all 45 degrees, and so on. This is 45, and that's 45 also. All right, so this was what, 3, 5 right here? And finally, we end up at 7, 5. So I think we can do the 7, 5 first. From here to here is 5, and therefore, since this side is also the same, that will be also 5. So we've got 5 here and 5 here. So we'd easily figure out that distance. A squared will be 5 squared plus 5 squared. That's 25 plus 25, root 50. Root 50, if I take the square root, would be 5 root 2. Okay, so we got that. Now let's figure out this guy here. From here to here is 7. If there to there is 5, that means from here to here is 2. So this is 2, and therefore that's 2 since that was isosceles. So similarly, b squared is equal to 2 squared plus 2 squared. So b squared is equal to 8, and therefore b is 2 root 2. Okay, top to bottom here was 5. This is 2, so that means this is 3. So this is 3, this is 3. And I can calculate that distance c. C squared will be 3 squared plus 3 squared. So that's going to be, what, 18? That's 3 root 2. So c is 3 root 2. Okay, so the total distance that the beam travels is a plus b plus c, which is 5 root 2 plus 2 root 2 plus 3 root 2. And that is 10 root 2. Number 11, the answer is C. All the roots of the polynomial are positive integers, possibly repeated. What is the value of b? Well, using our famous Vieta's formula, the sum of the roots is minus b over a. In this case, that would be minus 10 over 1, which is 10. That's the sum of the roots. The product of the roots, that is given by z over a, and in our case, that's 16 over 1, which of course is just 16. So now how many roots are there with z to the power of 6? So 6 roots. So we have to have 6 numbers that when you add them equals 10, but when you multiply them all, 16. And after a little bit of thinking, you come up with the following: 2, 2, 2, 2, 1, 1. If you take those 6 numbers and add them, they equal 10. If you multiply them together, they will give 16. So that means my polynomial is z minus 2 to the power of 4, z minus 1 to the power of 2. Okay, so now we do what nobody likes to do, which is expansion. So z squared minus 4z plus 4. And then I'll do that again, z squared minus 4z plus 4. And then z squared minus 2z plus 1. Okay. Now, Let's expand this out. Z to the power of 4 minus 4z cubed plus, I believe, 4z squared minus 4z cubed plus 16z squared minus 16z plus 4z squared minus 16z plus 16. And of course we got this z squared minus 2z plus 1. Collecting like terms, we get z to the power of 4 minus 8z cubed plus 24z squared minus 32z plus 16, and that part stays the same. Now, I don't need to expand it once again because I really just want the coefficient, what is it, b, right? So b is the coefficient of z to the power of 3. So I really just want what goes in front of z to the power of 3. Okay, when I multiply z to the power of 4 by any of these, it'll be more than z to the power of 3. But if I multiply that by 1, I get the first part of the coefficient, negative 8. If I multiply this by this, it would give me z to the power of 3, and that would be minus 48. And this multiplied by that would give me a z to the power of 3, namely minus 32. So z to the power of 3, when you add all those, is minus 88. And that is the coefficient, and that is what's represented by the letter b. So therefore b is minus 88, which is A for number 12. Out of the following complex numbers z, which one has a property that z to the fifth has the greatest real part? Okay, let's go through these. A, minus 2 to the fifth, and that's the easiest one. That's just minus 32 plus 0i. There is no imaginary part. There is a real part. B, minus 3 plus minus root 3 plus I. And we are going to the painful task of multiplying this out 5 times. And I am certain that you know how to do this, and you do not need to listen to me go through it all. When you do all this out and collect like terms, you get 16 root 3 plus 16i. And then similarly with C, when you multiply that out 5 times, you get 16 root 2 minus 16 root 2i. And then for D, you would get minus 16 root 3i. And then E is an easy one. 2i to the power of fifth is just going to be 32 times I to the fifth. And I to the fifth is the same as I. So that's just 32i. And that has no real part. So the largest real part, well, let's just circle the real parts. And here was 0. So the largest, obviously, is this one right here. So the answer would be B. Now, of course, it's very time consuming to do that. I just, gave you, after, expanding and collecting like terms, but you would have to do it, the full way. And therefore, I encourage you to learn about de Moivre's theorem. That will help you do this kind of problem much faster. And as always on a math contest, you want to do things as fast as possible. What is the value of this expression? Well, there is a very helpful log rule that if you have the log of a to the n and the base is b to the n, then that is just the same as the log of a to the base b. Now, you say, well, I'm not convinced of that. Okay, no problem. Then you can use the change of base rule to figure out that this is indeed true. So, change of base rule. If we have the log of a to the n, b to the n, you can change the base. You can just make the base x anything you want, a to the n, and it will be over the log of base, same base, x, b to the n. This is a rule of logarithms. And then the n comes out front, so we have the log of a to the base x, and then same thing down here, the log of b to the base x. As you can see, the n's cancel, and therefore you just get this, but this is the same as a to the base b, log of a to the base b. So as you can see, this does indeed equal that, as I had previously written. Okay, so that rule is going to be very helpful to figure this out. So here we go. Using that rule, we would have the following. The sum from k equals 1 to 20. The k squared, we can bring it out front, but before I do, let me just write it in the side here. K squared is really the same as 3 to the k to the power of k, right? So that's why I'm able to bring it out front. I just wanted to put that in there. So we have the log of 3 to the power of k to the base 5k. And then the other one is the sum from k equals 1 to 100 of, well, I can use the rule now. This rule right here. When I do, all I'm left with is just the log of 25 to the base 9. Okay, that's really helpful because that's just a constant. So that just means that every time you have a k, it's just going to give you this. This is just some number. I'm not really sure what that number is. It's probably less than 2 because the log of 81 to the base 9 would be 2. But whatever it is, it doesn't really matter. It's just going to be 100 times that. Because for every single one of those, you'll get that once. So it'll be log 25 to the base 9 plus log 25 to the base 9 plus log 25 to the base 9 100 times. So that's why that becomes 100 times the log of 25 to the base 9. Now this guy here is a little bit more complicated, but it shouldn't be too bad. So again, this part, you can use our really nice rule to get rid of those k's, and that will just give me log of 3 to the base 5, and then we have k, 1 to 20. All right, so that's pretty good progress, I think. Okay, so now we have to talk about this. So this will be like 1 plus 2 plus 3 all the way up into 20, and this is just a constant. So since it's a constant, we can just put it out front. Log of 3 to the base 5, and then it'll just be this now, and that's just 1 plus 2 plus 3 plus ... all the way to 20. And then don't forget about this guy, 100 log of 25 to the base 9. Okay, well this you can easily do with that rule. 20 times 21 divided by 2. And this doesn't change, hasn't changed yet. Okay, so now what I'll have to do is, again, a change of base rule. And this is what I'm going to change the base for. So I'll do it here on the side. Log of 25 to the base 9. Well, that is the same as the log of 5 squared to the base 9. The 2 comes out front. 5 to the base 9. There's a rule in the log world that the log of a to the base b is the same as 1 over the log of b to the base a. So I'll use that. This is the same as 2 times 1 over the log of 9 to the base 5. So that is the same as the log of 3 squared to the base 5, and that you can bring the 2 out front, the log of 3 to the base 5, and then 2's cancel, and you just get the log of 3 to the base 5. So all of that is pretty much what this is. So here we have the log of 3 to the base 5. Then this is what, 210. Then we have 100. And then we have this, which I have simplified to 1 over the log of 3 to the base 5. And this guy cancels with that. So in the end, all I'm left with is just 21000. 21,000 is the answer, and therefore number 14, that would be E. A choir direction must select a group of singers, choir director probably, from among 6 tenors and 8 basses. The only requirement is that the difference between the number of tenors and basses must be a multiple of 4. The group must have at least one singer. N is the number of different groups that could be selected. What is the remainder when n is divided by 100? Well, let's make a table and off we go. We will put t here, b here, and then t minus b, and see what we get. So t minus b, the difference has to be some multiple of 4. So it could probably be 0, or it could probably be 4. And I think that would be it. I don't think there's any way of getting 8. And then b minus t, same story. Well, b minus t, t minus b is the same thing if it's 0. But b minus t could also be 4. And I think we can also squeeze an 8 from b minus t since there's 8 bases. Okay, so let's figure this out. So t minus b, 0. We can get 1 and 1, 2 and 2, and so on, right? 3 and 3, 4, 4, 5, 5, and 6, 6. And then after that, we can't do any more because there's only 6 tenors. Okay? Now let's get t minus b, 4. For 4, it'd be 4 and 0, 5 and 1, 6 and 2. And I think that's it because there's only 6 tenors. Okay, I think we're exhausted the t minus b. Now we're going to do the b minus t. So now this is going to be b minus t. It's still going to be t and b in the other columns, but now we're doing b minus t. B minus t, we only have 2 choices, 4 and 8. If it's 4, b minus t, that can be accomplished with 4 and 0, 5 and 1, 6 and 2, 7 and 3, 8 and 4. That's 4. And then if b minus t is 8, the only way to accomplish that is 8 and 0. All right, so that is the table. So now let's talk about this. For the first one, if I want 1 t, that means from the 6 t's, I choose 1. And then if I want 1 b, from the 8 b's, I choose 1. And then I get what that is equal to. And that is 48. So that's how you're going to do this. So similarly, for the next one, from the 6 t's, I choose 2. From the 8 b's, I choose 2. And then I multiply those, and that is 420. Let's do a couple more. 6 choose 3, and then 8 choose 3. And when I multiply that, that's 1120. So you get the hang of it. So I'll fill this out, and then I'll come back and talk to you about it. So there you go. You get the hang of it. And then in the end, you have to add up all those numbers. And when you do, you get 4095. And that is basically the value for n. And they're saying that when you take that and divide by 100, what is the remainder? Well, it looks like it will be 40 with a remainder of 95. So number 15, the answer is D. In the following list of numbers, the integer n appears n times in the list for n between 1 and 200 inclusive. What is the median of the numbers in this list? Let's start off with a very simple example. Let's say there's 4 numbers, and I said, what's the median? Well, you take the second number and the third number and add them and divide by 2. It would be the average of those 2 middle numbers. But we don't have 4. We have, I don't even know how much we have. We have a lot. The first I have to do is figure out what is the total number. Well, the total number of terms in this list, I guess, would be 1, then 2, plus 3 of those 3s, plus 4 of those 4s, and then ... You get the idea. Eventually, you're going to have 200 2s, 200 200s. That's what I meant to say. So this is the number of terms in the list. Well, you know that formula for consecutive numbers. So that's the formula I'll use. Divide that by 2, and when you do this math, you get 20100. So this is how many terms there are in that entire list. So the median, very similar, would be the average of the middle two. Well, the middle two would be as follows, ... If you kept going, the middle two would be this one and this one, which would be half of this, would be this one here, which would be 10050, 10050. And then this guy would be the next one, the 10051 term. So if I can find these two terms, I'll add them, take the average, and I've got the median of the list. Okay, so how do I do that? Well, we have to figure out what number comes here and what number comes here. Well, I don't really know that, but I know that I can try to get close to that number. So 1 plus 2 plus 3 plus ... all the way up to some number n will perhaps be close to that. I mean, I don't know if it'll be exact, but it'll be close. So let's see. The sum of this, of course, is n times n plus 1 over 2. And I want that to be sufficiently close to 10050. It'll give me some sort of an idea of what the number will be. Okay, so let's work with this. N times n plus 1 cross multiply, and that's going to be 20100. Now I don't have to, use a quadratic. This is just an estimate, right? So this is like really very similar to n times n is equal to 20100. So it's kind of like n squared, right? So take the square root. Take the square root of this number. And when you do, you get approximately 141. So I'm confident that either sufficiently close to here, there'll be 141, a whole bunch of 141. So let's see what we get. 141 times 142 divided by 2, right? That's, I'm trying to figure out what are the number of terms all the way up until 141. That's the formula that you'd use right there. And when you do this math, you get 10011. So when we get to that term, that's the last 141. The next term after that would be 142. So these would be 142, 142. So after this, you would have 142 142s. So there we go. I just have to take the average of these two. Well, obviously, the average of those two will be 142. So number 16, the answer is C. Trapezoid ABCD has AB parallel to CD, BC is equal to CD is equal to 43. AD is perpendicular to BD. O represent the intersection of the diagonals AC and BD, and let P be the midpoint of BD. OP is 11. The length AD can be written in the form m square root of n. What is m plus n? Well, our first task is to try to figure out what this looks like. So first I have to draw it in a way so that this becomes a right angle. And I think that is pretty decent. That's a pretty decent right angle. And then I've got to draw an isosceles triangle here. So, and that's got to be parallel. So I think that's good enough. Not perfect, but that's good enough. So this is isosceles. That's a right angle. And let's label this now. So A, B, C, D, and then AB is parallel to CD. Okay. B is equal to BC is equal to CD, and then both of those are 43. And then AD is perpendicular to BD. Okay, perfect. So we got it all. And then what are they saying here? O is the intersection of AC and BD. AC and BD. Okay, I got to draw another line. AC to BD. That intersection they're calling O. So this is O here. And then P is the midpoint of BD. Okay, so midpoint approximately here. So that's P. And OP is 11, so that distance is 11. All right, and then we have to figure out AD. So find AD. And that is equal to m root n. And then in the end, we have to figure out m plus n. Okay. So I very much think there's a lot of similar triangles in this one. That just screams similar triangles. Because as soon as I saw parallel, that means they're going to use that Z pattern and all that stuff. Okay, so the first thing I'm going to do is draw a line from C to P. And that's going to be a perpendicular line. And that, because it's isosceles, chops BD in half. So for example, if the distance from there to there is, say, x, then that means this distance would be 11 plus x. It's got to be the same. All right. Okay, so from similar triangles, the first similar triangle I see is that BPC is going to have the same angles as BDA, triangle BDA. Triangle BDA. Yeah, because both of those have 90, and both of those would have a theta, because it's isosceles. So if this is theta, then this is theta also, right? Those two angles have to be the same. So both of those triangles would have a 90 and a theta, and then of course the third angle would be 90 minus theta, so they have all three angles the same. All right, so from that, BP over BC would be equivalent to BD over AB. So that means in terms of my labeling, x plus 11 over 43 would be the same as 2 times x plus 11 over over AB, sorry. So cross multiply, and it looks like the x plus 11's cancel, so AB just equals 86. Okay, well that was pretty quick. All right, so I think we have one more similar triangle relationship to look at, and that's ABO is similar to triangle CDO. Because of opposite angles, this angle will be the same as that angle, and then they already share a theta, and then the third angle would be whatever. They would be the same pretty much. So from this relationship, we get DC over OD is equal to AB over BO. So that would mean 43, DC is 43, OD is X, AB I just got was 86, and then BO is X plus 22. So we've got to do a little bit of math here. Cross multiply and you get 86x is equal to 43x plus 43 times 22. So that means 43x is 43 times 22. And therefore x has got to be 22. So dB I can figure out next. dB obviously would be 2x plus 22, and therefore when you substitute x equals 22, that just becomes 66. All right, the final step, I guess, would be to figure out AD, and I think I can do that using Pythagoras pretty quickly. AD squared plus DB squared is equal to AB squared. So AD squared will be AB squared, which is 86 squared, minus DB squared, which is minus 66 squared. So AD squared would be 3040, and therefore when you take the square root and do the necessary math, it'll be 4 root 190. So finally, m plus n, well, this is in the form m root n, so my m is 4, my n is 190, and therefore m plus n is 194. Number 17 would be D. Let f be a function defined on the set of positive rational numbers with the property that f at a times b is equal to f at a plus f at b for all positive rational numbers a, b. Furthermore, suppose that f also has the property that f at p is equal to p for every prime number p, for which of the following numbers is f at x less than 0. we have to go through the answer choices. And I'm going to go through, I'll go through all of them. Why not? So let's start with 17 over 32. F at 17, since f is a prime, 17 is a prime number, that's just going to be 17 according to their definition. 32, however, is not a prime number, but we can break it up using that. We can break it up using 2 and 16. Well, 2 is a prime, so that just becomes 2. F at 16 is not a prime. Well, 16 is not a prime, that's what I meant to say. But that can be broken up into f at 2 plus f at 8. So we have 2, again, 2 here, and then f at 8 can be broken up into f at 2 plus f at 4. And then this is, again, a whole bunch of 2's, and this one can be broken up into f at 4 times f at 2 times f at 2. So that looks like 5 2's, that's equal to 10. So that means this 17 over 32 is really just 17 over, and that's obviously greater than 1. We want something eventually that's less than 1. Okay, and in particular, it was f at that. We just broke it up into f at 17 plus f at, or rather divided by f at 32. All right, so we got to do the same thing for all these other ones. So f at 11 over 16. So that's going to be f at 11 over f at 16. So f at 11, that's just prime. That's 11. F at 16, using the same technique, we actually did that here, right here. And that's just going to be 8. So again, this is greater than 1. Okay, so that's gone, that's gone. How about the next one? 7 over 9. F at 7 over f at 9. F at 7 is just 7 because that's prime. F at 9 is f at 3 plus f at 3. Since those are prime, you have 7 over 3 plus 3. 7 over 6, which is greater than 1. That's gone. Okay, eventually we're going to get it. F at 7 over f at 6. So that's 7. And this looks like f at 2 plus f at 3. And that's 7 plus over 2 plus 3, which is obviously 7 over 5, which is greater than 1. Okay, by process of elimination, the answer's got to be E, but let's just do E and see why that is indeed less than 1. F at 25 over f at 11. Well, f at 25 is f at 5 plus f at 5. F at 11 is just 11 because that's a prime. And f at 5 is a 5 because 5 is a prime. So we have 5 plus 5 over 11, which is 10 over 11. And finally, that's less than 1. So number 18, the answer is E. How many solutions does the equation the sine of pi over 2 cos x equals cos of pi over 2 sine x have in the closed interval 0 to pi? Well, I think the best thing to do is just to make a very rough plot. And to make a rough plot, we will just need a few of these points. Now we have to do them within that interval 0 to pi. So let's just choose some points between 0 and pi. I'll choose 0, pi over 2, and pi. And then I will make a rough sketch of what this looks like. So we're really only looking at 2 quadrants since we're starting at 0. All right, so here we go. So first I will figure out cos x, and then the pi over 2 times cos x, and then finally sine of pi over 2 cos x. So I'm concentrating on the left side first. When x is 0, cos of x is 1. And therefore this would just become pi over 2. And then the sine of that, pi over 2, is 1. Okay? So when x is 0, it looks like 1 is the point. So this is 1 and this is 0. When x is pi over 2, cos of x is 0. Therefore this would be 0, and therefore the sine of 0 is 0. Okay? So when we have pi over 2, which is what, approximately 3.14 divided by 2, 1.6 or something. 1.55 or something. So approximately here, it's 0. And then we are going to do pi next. So cos of pi is -1. And then therefore this would be minus pi over 2. And the cos of minus pi over 2 is -1. So when we have pi, this is pi over 2. When it's pi, it's -1. So approximately down here. So I don't know what this looks like, but it's obviously going to be something like that, right? It's not going to be a straight line because sines and cosines don't behave as straight lines. They're always curves. If you remember, they're always curves like that. Okay, so I took care of the left side. Now let's talk about the right side, which is right there. Same story. So we have the sine of x, then we'll have pi over 2 times the sine of x. Then we have cos pi over 2 times the sine of x. So when x is 0, sine of x is 0. And therefore this becomes 0. And then we have the cos of 0, which is 1. So 0 would give me 1. So, well, we're right back here. So obviously that's 1 point of intersection. Okay, that's good. Let's just put a little red dot there. And then next we have pi over 2. So that's going to be 1 for sine of x. Therefore this will just be pi over 2. And this one is 0. So when pi over 2, it is 0. So it looks like that's another point of intersection. Okay. And the last one, when we have x equal to pi, sine of pi is 0, and therefore this is 0, and then the cos of 0 is 1. So that is up here somewhere. So that makes me think that the other graph, draw it in a different color, it's something like this. Not entirely sure how it goes, but something like that. And then I was able to get the graph off of Desmos. It's a nice website that you can make graphs. And this is what the actual graph looks like. I have so far 2 points of intersection, so let's see if I'm correct. And here's the actual graph, so not bad, but relatively decent sort of approximation. And as you can see from this graph, there's one intersection here, one intersection there. In the interval 0 to pi, pi is 3.14, so pi is approximately there because this is in radians. All right, so that would be 2 points of intersection. Therefore, number 19, the answer is C. Suppose that on a parabola with vertex V and a focus F, there exists a point A such that AF is 20 and AV is 21. What is the sum of all possible values of the length FV? Just in case you forgot, here is a review of parabolas and the focus and the directrix. So here's the parabola right here, and then this is the focus. Now, the rule is that if you take the focus and you draw a line to the parabola, it will be the same distance as the line drawn from the directrix to the parabola. Anywhere on that parabola, here also. And that's what those symbols mean, as I'm sure you know, that those are the same length. So we'll do the same thing, but we'll do it this time on a slightly different curve, and off we go. So here's my parabola, and the focus is going to be the same distance from the directrix. So here's F, here's the directrix line right here, and this is obviously the parabola. We can call it P, we don't really need to call it. And this is obviously the vertex right here. So this distance is the same as that distance. Now they are giving us another point and they're calling it A. So A is somewhere, I'm not sure where, let's just say it's here. And we'll call that A right there. And let's draw those lines now. So F to A will be the same distance as A down to the bottom. May not look like it, sorry about that. Not perfectly drawn to scale, but you guys understand. Okay, and anything else that they've given us? Yeah, V to A. That also has been given as a distance. And I think the rest is up to us to label. So now I have to label this. So I'll just call this x here, y there, and then I think I'll make a box to create some Pythagorean relationships. So I'll extend this line up here, and then I'll go straight across, and I think I'll go straight across from V as well, and that should do it. And then I've got to label some stuff. I'll just call this M, and I'll just call this Z. Okay, so let's talk about this now. So by definition, as I had previously mentioned, FV is the same as Vx, right? So we'll just call that D for now, that distance. That we'll just say that's D. And then also by definition, FA is the same as AY. And that actually they've given us in the question, it's 20. Okay, so that's very, very helpful. So now I guess I can get some Pythagorean relationships. First, let's label this. I'm going to label AZ, this distance right here. AZ looks like 20 minus D, right? Because A to Y is 20, and then the distance from Z to Y is D. It's the same as the distance from V to X. So AZ looks like it is 20 minus D. And then AM, this one I also need. I need that distance as well to figure out some Pythagorean relationships. AM looks like 2D minus AY, which is 20. So 2D minus 20. 2D minus 20. Okay, now we're ready for Pythagorean relationships, and here we go. So the first one, I'm going to use this one, this triangle right here. And then the next one, I'll use that triangle right there. So from the first one, I get AV, and that is 21 squared. A is equal to VZ squared plus AZ squared, which is 20 minus D squared. So that means 21 squared minus 20 minus D squared is equal to VZ squared. And then from that triangle, I get FA, which is the hypotenuse there, which is 20 squared, is equal to FM squared plus MA, or AM, which is 2D minus 20 squared. And I can isolate for this 20 squared minus 2D minus 20 all squared. And that's FM squared. Well, FM is the same as VZ, right? Because we've drawn it in a way so that's a rectangle. So I can just set those equal to each other, since FM is equal to VZ. So therefore FM squared will be equal to VZ squared, which is 20 squared, 2D minus 20 squared is equal to 21 squared minus 20 minus D squared. Okay, it's relatively reasonable math at this point. So let's do this without making any mistakes. 21 squared is 441, and then bring the 20 squared over, that'll be 400. And then expand this here. If I bring this over, it becomes positive, and then if I start expanding, it'll be 400 minus 40D plus D squared. This one, minus 4D squared plus 80D minus 400. Okay, now let's collect like terms. Let's see, the 400s cancel. I get here minus 3D squared plus 40D, and on this side I get 41. Put everything on one side, and I get 3D squared minus 40D plus 41. Now this obviously has some roots, and they want all possible values of, let's see here, all possible values of FV, and FV is D. So all possible values of D, and they want the sum, right? So basically what it boils down to is getting the sum of the roots. And the sum of the roots, as you hopefully know by now, can be calculated with Vietas, which is just minus B over A. And in this case, that would be minus minus 40 over 3, which is 40 over 3. So there we go. That's the answer to a relatively decent question, number 20. That would be B.